All right, kids, so we're going to start talking about the point slope formula or point slope form. And really, it just comes from this slope formula that we've messed with before. So to get point slope form, what they do is they take this equation and we're going to multiply it by x2 minus x1. All right, multiply both sides to clear out that denominator. So x2 minus x1. So on the right-hand side, the stuff up top cancels with the stuff on the bottom. And what you end up with is on the left side, you get m parentheses x2 minus x1. And on the right side, you get y2 minus y1. What I'm going to do is I'm going to rearrange these. Now, instead of writing y2 and y1, what they do is so I'm going to move this one over here, is they write y minus and they write y sub 0. All right, so this is going to represent any point, all right, the y coordinate for any point. And this is going to be, you know how we have y equal mx plus b? Well, the x and the y, this is like that y part, all right, like that. And then on the right side, you've got your m, and then instead of an x2, they've got an x minus, and then instead of an x1, they replace that with an x sub 0 as well. So this is the point slope formula, and we're going to talk about we're really just substituting in values for x naught and y naught, and for the m is what we're doing. So it's going to be a simple way to write specific equations is what it's going to be. But it generally comes from this slope formula. All right. So what I've got down here is I've got an equation in slope-intercept form and an equation in point slope form. And I just want to show you a thing or two about it real quick. So these are actually the exact same line. It's really hard to tell from the way that they're written. But the way it's going to work is no matter what point that I try to plug in to either of these, you're going to see that it satisfies both equations, right? So like if I take 2 and I plug that in for x, negative 1/2, and I plug in a 2 for x, plus 5. If I crunch these numbers, it's going to spit back a 4 for the y, all right? Negative 1/2 times 2, that's equal to negative 1. Negative 1 plus 5, that is equal to 4. So that just means that this point is on this line, right? And this is the only way that you can write this particular equation in slope-intercept form. There's no other way. But here in a second, I'm going to show you there's a lot of ways that you can write it in point-slope form. A lot of ways. So to get my equation in point-slope form, I just replaced this x naught with a 2 because the 2 was like my x value. And to get the y naught, I replaced, to get the 4 here, I replaced my y naught with this 4 right there. All right. And then m, that was still my 1/2, just like it was the negative 1/2 over here. All right. But if I plug in, what's nice about point slope form is that if I plug in these values, you actually get 0 immediately back on both sides. And so it balances. So if I plug in 4 for y, I get 4 minus 4. And then if I plug in 2 for x, I get 2 minus 2. So I get 0. And then over here, I get 0. And then negative 1/2 times 0, still get 0. So the equation balances, and therefore that point is on this line. All right. Now I didn't have to plug in 2. I could have plugged in a different number for x. Let me show you how I can get another equation besides this one. Let's say, let's pick a different value for x. Let's say I plugged in negative 6. Okay, let me crunch these numbers here. Negative 1/2 times negative 6, that's going to be 3. 3 plus 5, that gives me 8. All right, so whenever x is equal to negative 6, the y value is equal to 8. All right, that was just picking a value for x, and I got a value back for y. So whenever x is equal to negative 6, y is equal to 8. But now I can go over here on my point slope form side, and I can just create another equation. It's not that bad. We'll do more of these examples later. And then x plus 6. See, this equation and this equation and this equation are actually all equivalent. All right, they may look completely different, but they will all operate and they will all balance the same. Like I can see here, if I take negative 6 and I plug that in for x, I'm going to get 0 right here. And if I plug in 8 for y right here, I'll get 0, and so it balances. I could even take negative 6 and plug it in for x up here, and take 8 and plug it in for y up here. Now the equation won't give me 0 back on both sides, but it will balance. It's going to give me 4 on the left side, and if I did it over here, it would also give me 4 on the right side. So the moral of the story is that there's only one equation that can be represented, slope-intercept form-wise, but there's multiple, an infinite amount that could be represented in point slope form.